Now let us begin the experiment to convert a galvanometer into voltmeter of desired range. Resistance and figure of merit of the galvanometer will be given. Now the principle involved is we can convert we can convert a galvanometer into voltmeter if we connect a high resistance in series with the galvanometer. So the principle is actually 2 marks. Then we have to write the formula, which is R is equal to V by Ig minus G. Here R is the resistance which must be connected in series, and that can be calculated. The value will be given by this formula, where V is the range of the conversion. For example, if the question says convert the galvanometer into voltmeter to range 0 to 3 volts, then V will be 3 volts. Otherwise, if they say 0 to 5 volts, V will be 5 volts. What is Ig? Ig is the current that produces full scale deflection in the galvanometer. So in the galvanometer usually we have 30 divisions. So a current that produces 30 divisions of deflection is Ig. So capital G is the resistance of galvanometer. Note that capital G will be given to you, and Ig is N into K, where N is the number of divisions in the galvanometer, which is 30. K will be given. K is nothing but the figure of merit of the galvanometer, and it is given to be 20 microamps per division. That means 20 microamps of current is required to produce 1 degree of deflection in the galvanometer. Now the least count of galvanometer is given by V by N, where V is the range of conversion. So if the range is 0 to 3 volts, then V is 3 volts. N is anyway always 30. This is the circuit diagram. So note the circuit diagram. G and R are in series. So that means my G and R will behave like an experimental voltmeter, and this voltmeter is there for reference. So I can write this will be my experimental voltmeter, and this is my for reference. That's the voltmeter for reference. So basically the reading that I am getting from G and R should be matching with the voltmeter, this reference voltmeter. Please note that this A, B, C, these form the 3 terminals of a rheostat, and they are all connected in parallel. So after making this connection, first write down the polarities. So battery positive. So since this is parallel connection, polarity will be maintained. So A will be positive, G will also be positive this side, and V also be positive this side. The other terminal will be negative, and they both from V negative and R, other side of R, both are going to C. I will show you what is C here. And this is the calculation part. So conversion range. So if the question says convert the galvanometer into voltmeter of range 0 to 3 volts, then what is the resistance that must be connected in series? That we can calculate using the formula which I have already mentioned here. So I have all plugged in the values already. So I'll get 4885 ohms. That is the resistance that I must be connecting with galvanometer in series for it to behave like a voltmeter. Now the least count of galvanometer is V by N, which is 0.1 volts. So let me show you the connection now. So we always start from the battery usually. So, and one more thing, the battery's power supply should be at least more than 3 volts, at least 3 volts. So I have connected to 4 volts. Why 3 volts? Because in the experiment I am converting the galvanometer to voltmeter of range 3 volts. So power supply should be at least 3 volts. Now you can see here from battery positive it's going to A. That's what I have done here. From battery positive it's going to A. So this is the terminal A. So either this is A or this is A, but I have chosen this to be terminal A. So that is connected to battery positive. You can see it's going to terminal A. Now from terminal A, one more wire is going to G. So you can connect it like this, from battery positive to A to G positive, and then from A to voltmeter positive, or from battery positive to A, then A to G, then G to V. Both are equivalent. So what I have done here, battery positive to A, then from A to G positive, that's what I have connected. Then from G positive it goes to voltmeter positive. So this side of the connection is done. Now galvanometer negative to R and other end of R to C. So galvanometer negative is going to R and the other end of R is going to C. Alright. Then voltmeter other end, which is the negative end, is also going to C via R. So that's what I've done. From voltmeter other end, that is also going to C via R. So I hope the connection is clear. And after that, I will remove in the resistance box 4885 volts, 885 ohms. So I have removed that. Then I'll switch on the battery. Now what I'll do, I'll move the rheostat such that I'll get 2 volts of reading in the voltmeter. So you can see that I am getting 2 volts in the voltmeter. So I'll write that here. So the voltmeter reading would be 2 volts. So correspondingly, what is the galvanometer reading, which is given by V by N, that is the least count of galvanometer into number of divisions. So you can see that the galvanometer reading is 21. So number of divisions would be 21 into least count of galvanometer. We already know it's 0.1, so it's 2.1. So the error is 0.1. For the next reading, I will again move the rheostat such that the voltmeter will show maybe 3 volts. You can keep it anywhere you like. Okay, and correspondingly, the galvanometer reading is going off 30 divisions, so I'll make it 2.5. Okay, this is voltmeter reading is now 2.5. Galvanometer reading should have been 25, but it's 26. So voltmeter reading is 2.5 and galvanometer reading is 26 into least count, which will give me 2.6. So the error is still 0.1. So like that you can do one more observation, and the result would be, since the error is negligible or small, in this case it is small, not negligible, so we can say that we have converted galvanometer into voltmeter of range 0 to 3 volts by connecting this 4885 ohms of resistance in series with galvanometer. So basically your calculation will give you 3 marks, and observation will give you 4 marks, and result 2 marks.